Okay, 7.2 is about multiplication and division of fractions. All right, it's about multiplication and division. So I'm going to ask you to remember some simple things about multiplication and division. When you multiply two fractions, let me go to a blank piece of paper. And what if I ask you to multiply, and you don't necessarily even need to write this down if you're taking notes. I'll come back to the problems. What if I ask you to multiply 12/15 times 5/16? Do you agree you could, if you wanted to, multiply the tops, multiply the bottoms, and then try to reduce your answer? Or you can look this way, this way, this way, and this way to see if maybe you could reduce or simplify beforehand. And what did I end up drawing? A bow tie. Kind of missed the knot, but there we go. I have a bow tie. So it's a little bit silly, but I'm going to say bow tie before you multiply. Yes, I rhymed. Bow tie before you multiply. Okay, you're probably way too mature for that silliness, but it will help you remember. You're going to look in all those directions to see if there's some reducing. Now, I hope the purple doesn't make it too hard to read. What could I reduce in this arithmetic fraction? 12 and 16 have a common factor of 4. 4 goes in there 3 times. 4 goes in there 4 times. What else? 5 and 15 have a common factor. 5 goes in there once. 5 goes in there 3 times. Do you see anything else? The 3's, and sometimes the vertical is overlooked. 3 goes into itself once. 3 goes into itself once. Multiply the leftovers, and sometimes it's hard to even see the leftovers. What would you get? You would get 1/4. Is that okay? All right. The other thing I'm going to ask you to remember is about division. This is just arithmetic stuff. What if you had 5/8 divided by 20 over 36? What do you have to do with a division problem? Okay, my little silliness here is going to be keep, change, flip. You're going to keep the first fraction exactly as it is. You're going to change the operation to its inverse, which is multiplication. You're going to flip, which is another inverse, that to 36 over 20. And now you will, quote, bow tie. What do you see that we could do? The 5 and the 20, okay, 5 goes in there once, 5 goes in there 4 times. What about 8 and 36? Do they have a common factor? 4 is the greatest. You could do 2 and then do 2 again, but 4 goes in there 2 times and 4 goes in there 9 times. Anything else? I don't think so. We get 9/8. And in here, we're completely happy with improper fractions. So does everybody remember how to multiply and divide? All right. We're going to do it now with algebraic fractions. And let's see. I have all these problems here, but I'm going to go ahead and go down to notebook paper and write them. Okay, problem number 1. You're supposed to multiply 3x over 4w squared times w over 7x. Bow tie before you multiply. And in this problem, these are monomials. These are already in factored form. It's already 7 times x, 4 times w squared. These don't need to be factored. Do you see any common factors, though? Okay, somebody said the x's. This x and that x. Divide out. What else do you see? W's. I have a single W here. I have W squared down here. So if I divide it, do you agree I get one W down there? Anything else? I don't think so. What do I have left? I have a 3 in the numerator. The denominator, I have 4 times W times 7. So I will call that 28W. When you finish a problem and you're ready to say it's done, always look at it and make sure you haven't overlooked some factoring that you missed over here. We didn't miss any, but I always look at it just in case. Is that okay? What do you have to do? These have to be in factored form. They already were in problem number 1. Problem number 2. I have x over 7x minus 35 times x squared minus 5x over 3. All right, I believe I can, when I see some pluses and minuses in here, it tells me I better look at these and see if they can be factored. Can the numerator of the first fraction be factored? No, it's just x. Can the denominator of the first fraction be factored? What do you see? 7 as a common factor. So 7 and the other factor will be x minus 5. Is everybody okay with that factoring? Times second fraction, numerator. Can I factor this numerator? What do you see? Common factor of x, x times x minus 5. The denominator is just a 3. So when you're going to multiply two fractions, you could have as many as 4 factoring problems to do in one problem. I only had 2. All right, do you see some common? X minus 5 and x minus 5. What about the x's? No, they're both on the top. Okay, I just wanted to tempt you with that, and I'm always going to do those mean kind of things. You just be firm and tell me no, you can't do that. So what do I have left? On the top, x times x is x squared over 21. That is the product, and it's in lowest terms. It is simplified. Let's look at number 3. The original problem is x squared minus 49 over x squared minus 5x minus 14 times x plus 2 over x. All right, before I do anything, what do I have to do in each of the 4 positions? Factor. Factor, factor, factor. You got to remember to always start out with that. First numerator, x squared minus 49. What comes to mind? Difference of squares. Y'all are getting really good. Difference of squares, that's going to factor into x plus 7 times x minus 7. And on the recording, that was someone very tired. All right. The denominator, trinomial, no common factor. Let's go with trial and error. The last sign is negative, which means I have one of each. I have x and x. I need factors of 14, which have a difference of 5. 7 and 2. And I will put the 7 with the negative because the middle term was negative, and the 2 there. And you would double check that. The second fraction, I don't think there's anything we can factor. X plus 2 can't be factored, and good old x can't be factored. So what do you see as common factors? I hear x plus 2, and I heard x minus 7. So what are we left with? The numerator is x plus 7, and it's over x. Okay, go ahead and mark out the x's now. No. Tell me no. That x belongs to the plus 7. You can't touch part of it without touching all of it. Okay. Number 4. All right, we've got a lot of trial and error in this problem. We have a squared plus 13a plus 40 over a squared plus 5a minus 14 times a squared plus 8a minus 20 over a squared plus 16a plus 64. I'm going to be quiet, pause the recording, and give y'all a couple of minutes to be working on this factoring. Okay, we have 4 trinomials to factor, and I will solicit help from the class. The first one. I know the last sign is positive. They both match the middle term, plus and plus, a and a. I need factors of 40 that add up to be 13, 8 and 5. Doesn't matter which one you put where. Denominator. There's no common factor. I'll go with trial and error, but this time the sign is negative, which tells me one of each. I need an A and an A. I need factors of 14 that, because the signs are different, have a difference of 5. 7 and 2. And I need the 7 to be positive because that was what the dominant one was, and the 2 down there. Okay, the numerator over here. Last sign is negative, so I need 1 plus and 1 minus. I need an A and an A. I need factors of 20 with a difference of 8. 10 and 2, with the 10 being the bigger one, has to go with the positive. Last one, I have last sign is positive, middle sign is positive, so they're both positive. I have an A and an A, and 8 and 8. 8 times 8 gives me 64. They add up to be 16. Okay, so however long it takes us to get through all that trial and error factoring. Do you see any common factors for me to divide out? Okay, I'll just, whatever you tell me. Okay, I heard an A minus 2, A plus 8, and is that all? I think so. Now, my math lab, for the most part, does what most math textbooks do. When you have a product multiplication problem, it leaves the answer in factored form. So it leaves the answer looking like this. And you do not have to use your FOIL to multiply it out. So don't FOIL. You're just going to leave it. All right, so when you get an answer like this, don't multiply it out. Just leave it. But I will tell you there's one inconsistency, and I'll tell you which problem it is where they do multiply something out. But I'll tell you about it so you'll know. All right, let's go. Is everybody okay with multiplication? Yeah. Okay. Let's go to division. Problem number 5. It says, find the quotient and simplify the result. Now, I may need just a little bit more room here. So, all right, the problem is 7x to the 5th over 2x to the 6th divided by 21x to the third over 10x to the fifth. Because it's division, what's my first step? All right, I've got to keep 7x to the fifth over 2x to the sixth, change it to multiplication, flip the second fraction, so it is 10x to the fifth over 21x to the third. These are those monomials again. These are not pluses and minuses, so I can go straight in there looking for common factors. What do you see? Let's do numbers first. 7 and 21. 7 goes into itself once. 7 goes into 21 3 times. What else do you see with numbers? 2 and 10. 2 goes into 2 once. 2 goes into 10 5 times. Now, with the x's, do you see lots and lots of factors of x's? There's a lot of ways you can go. You could work up and down, or you can work on diagonals, or maybe both. Any way you want to go is okay. So, it's going to get a little cluttered. How do you want me to go? Diagonal. Somebody says diagonal, I'll go with it. So, I'm going to start out by looking at an x to the fifth and the diagonal x to the sixth. If there are 5 factors of x up here and 6 of them down here, do you agree that 5 of those will go away and you'll have a single factor of x left over? Okay. Now let's look at this diagonal. I have an x to the third and x to the fifth. These 3 will knock out 3 of these, leaving x to the second. And I'm not quite done, even though I have a big clutter of red marks up here. I took care of my numbers, and I've taken care of my variables, but I still have an x to the second over an x. So can I still reduce further? Yeah. Yes. This x divides out with one of these x's, leaving me an x up there. So what in the world do I have left? I have 1 times x times 5, which is 5x over 3.
Would you get the same answers if you do up and down?
Yes. You could do up and down x's and then see if there are any diagonals left. All right, number 6. It seems as if MathLab sort of breaks its own rule with something with number 6. So I'm putting a little circle around it because when you do number 6, I'm guessing the same thing's going to happen. All right. Starts out as a division problem. So I have a squared minus b squared over a minus b divided by a over a squared minus ba. All right, first thing I need to do is keep change flip. Keep the first one, a squared minus b squared over a minus b, change to multiplication. Invert the second fraction, a squared minus ba over a. Now what do I need to do? I'd like to bow tie. Before I can bow tie, I have to factor. If you work through a problem and you haven't factored, the only kind of problem that you should be doing that on would be one like this, where there is no factoring to be done. But if you've got any pluses or minuses, you better be factoring. All right, numerator of the first fraction. What do you recognize? Squares, difference of squares. A squared minus b squared. It factors into a sum and a difference. A plus b, a minus b. Denominator. Is there anything I can do with the expression a minus b? Okay, numerator of the second fraction. Is there anything I can do to factor this one? Greatest common factor of A. A times A minus B. And is there anything I can do to the denominator? No, it's just an A. Do you see any common factors for me to divide out? Yes. Here's an A minus B, and here's an A minus B, although you could have done the up and down ones. It's your choice. What else do you see? Just the single factors of A. So I think that leaves us with A plus B times A minus B. Now let me say this. If you were taking a test, I would think that would be your final answer. Leave it in factored form. That's what I'm always going to say to do. I'm so sorry. For some strange reason, my math lab decided only on problem number 6 to multiply those together. I don't know why. But if you multiply those, it's a sum and difference product. You're back to A squared minus B squared. On this one, MML multiplies. And I don't know why, and I wouldn't. But I'm assuming that you'll need to as well. All right, there are a gazillion problems. We're going to skip several. All right, if you take a quick look at number 7, the only thing in number 7 that I would call your attention to is this denominator is an 8 minus x. When you do keep, change, flip, you're going to have a numerator that is going to be, you're going to have an x minus 8 up here. What do you notice about 8 minus x and x minus 8? They're opposites. So when you divide those out, make sure you leave a factor of -1 with your answer. Okay? So I'll just mention that on number 7. We're going to jump. There's a multiplication problem on number 8. Number 9 has a multiplication problem, and we're going to go all the way to number 10. And this will be our last problem. All right, it is division, so let me write it out where those of you in the classroom can see it. It is 28n squared minus 847 over 2n squared minus 15n plus 22 divided by 6n squared plus 23n minus 55 over n squared minus 8n plus 12. Now that's the original problem, but it's division. So we all have the joy of rewriting it as a multiplication problem. It is 28n squared minus 847 over 2n squared minus 15n plus 22 times, flip the second one, n squared minus 8n plus 12 over 6n squared plus 23n minus 55. Okay, now something I'd like to do is that this looks like quite a bit of factoring. Agreed? I'm going to go off completely down here and just write out my factoring. The first one is 28n squared minus 847. What can I do? Do you think there might be a common factor? I hope so, because that's a square. So I'm hoping for difference of squares, but 28's not a perfect square, and I don't think 847 is. So I've got some of y'all with calculators piddling with it. What will go into both of those? Seven. Somebody says 7. Now here's something that might have been a clue. 28. It's not a perfect square. What are the common factors of 28? 4 and 7? 4 is a perfect square. I'd like to keep it, which means I'd like to factor out the 7. Check and see if 7 goes into that. It does. If I factor out the 7, 7 goes in there, 4n squared. And if I factor out the 7, I get 121. Well, is that binomial the difference of squares? Yes. Keep the 7. 1 sum, 1 minus. That gives me 2n plus 11 and 2n minus 11. That was all to factor the first numerator. Back to my problem. So I have 7 parentheses 2n plus 11 times 2n minus 11. Is everybody pretty tired? Would you like me just to write down the correct factors for all the others? Do you want the challenge? All right, this bottom one. Let's see if we can just do it. It shouldn't be too bad because that's a plus, which means both factors are minus minus. I know one of them has to be a 2n and one of them has to be an n. I need factors of 22. What do you think I'll use? 22. 2 and 11. 11 and 2. Check them. They're right. I made them happen. I have the answers written right here. It's called cheating. Okay. This numerator, the last sign is plus, which means both signs match the middle term. They're both minuses. I need an n and an n. I need factors of 12, which add up to be 8. 6 and 2. This denominator, there are quite a few possibilities, and I am going to save us a little time. We know that the last sign is negative, so I need 1 plus and 1 minus, and I will get 2n plus 11 and 3n minus 5. There were probably quite a few possibilities there. So, we have all of this. Do you see some common factors? Yes. I see a 2n plus 11 and a 2n plus 11. 2n minus 11, 2n minus 11. n minus 2, n minus 2. Okay. In my first class today, when I was doing this problem, I miscopied the problem. Nobody said anything. So we did all this, and the problem I made up was factorable. We got all these factors, and nothing canceled out. They were upset with me, especially when I said, oh, that was the wrong problem. We need to start that one over. I wasn't popular. It's a good thing I couldn't read their minds. All right, so I have 7 times n minus 6 over 3n minus 5. And you really should not multiply that 7 times those, and I checked the answer on this one, and MathLab doesn't. Only number 6 did I find that it multiplied anything out.
You don't put one of those like that.
I would not. No. Now, there could be one with 4 things to factor like that, but not something with all these possibilities. No. Okay, so are we good with that? And I'll say some concluding remarks. Okay, in section 7.1, we're going to start out talking about what is domain. The domain will be the numbers you can put in the place of x. The numbers that you can put in the place of x. Now, before we look at these problems, as an example, if you had y equals, and I'm looking at relationships here now between y and x, if I had y equals 2x plus 1, and I said, what is the domain of this? Well, I'm asking you, what are all of the numbers that you could put in the place of x? Okay, could you put any positive number? Yes, you could put in any positive number for x. You could multiply it by 2, add 1 to it, and out would pop an answer. Could you put negative numbers in? All right, can we put in negatives? Yes. Could we put in 0?
Yeah.
Could we put in fractions? We might not want to, but could we?
Yeah.
Okay, decimals, square roots even if we wanted to. We could put in anything. So the domain is the set of, and I'm going to write some weirdo algebra notation. It's the set of all x's such that x is a real number. X is a real number. You can plug in what we said a few minutes ago, any number you please. The domain is all the real numbers. We're about to look at, in Chapter 7, and starting with 7.1, and I will enlarge that for those of you currently in the classroom, we're going to look at some relationships that involve rational expressions. Rational expressions, rational is a fancy math way of saying fractional. This entire chapter is about rationals, which is another way of saying it's about fractions. All right, those of you who have had Math 307 in the recent past probably remember f of x is a way of function notation. We did this when we were in Chapter 3. Function notation. Don't worry about it. F of x is nothing more than another way to write letter y. Okay? So, if I had y equals 7 over 5 minus x. If I have that relationship, and I ask you the question, what is the domain? You say, well, what can you plug in for x? Well, you start out by saying, I bet I can plug in just about anything. Okay? But this is a rational expression. It's a fraction. There is a rule about fractions, and a particular number cannot be in a particular place. Do you know what number I'm talking about? 0. And where can 0 not be in a fraction? The denominator. Okay, there is a rule that says you cannot divide by 0. 0 cannot be in the denominator. So what we're going to do to figure out the domain is I'm going to start out and I'm going to say, can you see this sentence right here? It says, the domain of f of x is the set of all x's such that x is a real number and x cannot equal blank. Okay? So we're going to have to fill in that blank. There is a number that x cannot be. The number it is, you're going to take the denominator, 5 minus x, and What is the value that you don't ever want it to become? 0. So I'm going to break the rules and say, well, what if it's equal to 0? And let's solve for that x. That is a linear equation. That's a linear equation. So what should I do to solve for x? Okay, you could subtract 5 from both sides. I have negative x is equal to negative 5. I'm not quite through. What else do I need to do? Okay, I need to divide by negative 1, and x is equal to 5. What did I just find? I found a number that if x is that number, what is the value of the denominator? If x is 5, what is the value of the denominator? 0. And is that allowed? No. So, the domain of this rational expression is x is a real number. It can be any number, but x cannot be, and that's a not equal to sign, what? 5. Your process is going to be to find a domain. You're going to set the denominator equal to 0, solve the equation, and then that answer is what x cannot be. Okay? Now, whoops, let me get back up here. Well, I had hoped I left myself some more room, but I didn't. Okay, so I will sneak this in wherever I need to. Let's go to number 2. Number 2, it says, find the domain of the rational function. All right, now the part of the answer is already here. The domain is x, it's the set of all x's such that x is a real number and x cannot equal. And I have to fill in the blank. How do I find out what x cannot equal? I described this just a second ago. Okay, we're going to write an equation. What equation? What do you not want to happen? I don't want the denominator to equal 0. So I take 2x plus 5, which is the denominator, and I break the rules. I set it equal to 0, so I'll find out what would cause the denominator to equal 0. That's a linear equation. Let's subtract 5. 2x is equal to negative 5. Divide by 2. X is equal to, let's leave it an improper fraction, negative 5 over 2. What did you just find? The number that makes the denominator equal to 0. And that number must be excluded from the domain. So the domain is all the real numbers, but x cannot equal, what will I put in here? Negative 5 over 2. And please go ahead and leave it as a fraction. Don't type it as a mixed number. Don't type it as a decimal. Is that okay?
What if we divide 5 by 2?
Do what?
What if we said to divide 5 by 2 to like 1?
So if you got 2.5, that's okay, but not for MATLAB. And how do you know that? It says in the instructions, type an integer, so that'd be a whole value, positive or negative, or a fraction. Okay, so don't give it a decimal. Don't give it a mixed number. Just leave it. All right, the third one, the last of those, number 3, it says, find the domain of the rational function. This one happened to, instead of using f of x, use the letter c of x. Don't let that bother you at all. How do I find out what the domain is? Remember, here's my answer. The domain is all real numbers, but x can't be. How do I do that?
X squared minus 25 equals 0.
Exactly. I take the denominator. I set it equal to 0. This problem, number 3, is a quadratic equation. Do you know how to solve quadratic equations? Yes, they were numbers 16, 17, and 18 on your test that you had. Quadratic equations. Factor, make sure it's equal to 0. It is. Common factor? No. Can you factor this binomial? It is the difference of squares. So I will factor it into 1 plus and 1 minus, an x and an x, a 5 and a 5. The difference of two squares factors into a sum and difference product. Using the zero factor property, I have x plus 5 equals 0 or x minus 5 equals 0. That tells me that x is negative 5 or x is positive 5. In this relationship, there are two numbers that you would not want x to become. If x is 5, 5 squared minus 25 would give you 0. If x is negative 5, negative 5 squared is also 25 minus 25 would give you 0. So because it's quadratic, there are two numbers I need to exclude from my domain, and they are negative 5, comma 5. It says if there's more than one answer, separate them with a comma. So if I want to go back up to the top, the domain for a rational, and I'm going to write that in caps, expression. I'm sorry. The domain for a rational expression. Set the denominator equal 0 and solve. That's what you're going to do. Is that okay? All right. There are 3 questions in MathLab that relate to that, and I would imagine that on your first test, you will have 1 question that will relate to that. Not your first test, your test over this chapter. All right, I'm going to try to make this one little bit bigger and see if we can do this. All right, question number 4. I don't know that you can very easily write all this down. To copy all this, it's a multiple choice question. It says, list 4 equivalent forms for the rational expression. Now, let me say this in general about rational expressions. I'm going to come right over here. Do you agree that a rational expression is going to have a numerator and it's going to have a denominator? Okay. There are 3 places where you could write a sign. The numerator could have a sign, positive or negative. The denominator could have a sign, positive or negative. And sometimes you will see a sign written out in front of the fraction. Do you recognize those 3 positions? Okay. If you have a fraction, if you change 2 of the 3 position signs, the fraction is equivalent. Example. Suppose I have negative 2/3. Do you agree that the numerator is negative, the fraction sign is positive, the denominator is positive? Change 2 of those, any 2 you want. Well, let's say I change the sign of the fraction to negative. Didn't want to stay. And I changed the numerator to positive. Did I just change 2 signs? I changed this one, and I changed this one. Are those 2 fractions equivalent? Is negative 2 divided by 3 the same as the fraction negative 2/3? Is a negative divided by a positive equal to a negative fraction? The answer is yes. Okay, now you're only going to see this discussion in this one question, so bear with me on this. This fraction has x minus 12 as its numerator. It has a negative out in front of it, and it has x plus 1 as its denominator. It wants me to go through these, and one, A, B, or C, one of them has 4 expressions which are all equivalent to this one. Okay, so what we're going to do is we're going to look at it and see, have they just changed 2 positions signs? So let's hang in here. All right, look at this first choice. It has negative in front of x minus 12. Do you agree that they've changed the sign of the numerator?
Yeah.
Okay. It has no sign in front of it, which implies positive. So do you agree they've changed that sign? And they have not changed anything about the bottom. So they changed 2 position signs. They changed the numerator and they changed the sign in front. And that means that is equivalent to the original. You change 2 positions and you're okay. No more, no less. Let's look at the next one. Okay. They did not change the denominator. They did change the sign in front because it disappeared, so it must have become a positive. Now look at the numerator. X minus 12, x plus 12. Is this the opposite of this? Well, the 12s are opposites, but are the x's opposites? No. X minus 12 and x plus 12 are not opposites. They changed a piece of it. They didn't change the entire numerator. So, they didn't change the bottom. They changed the sign in front. We need one more sign change. Did they change the entire numerator? No, they changed part of the numerator. This is not equal to that. So, what that tells me is choice A is not the right list. Okay, let's go on. So just bear with me because I know this is tedious. All right, look at choice B. Well, we have already said that negative parentheses x minus 12 over x plus 1 is the same as the original because there were 2 sign position changes. Let's look at this. Whoops, got to keep that one up there. All right, the numerator. Is this numerator, x minus 12, has it entirely had its sign changed?
Yeah.
Yes, positive x went to negative x, negative 12 went to positive 12. They changed the sign on the top. Did they change the sign out in front?
Yes.
Yes. Did they change the sign on the bottom? No. Then they made 2 changes, numerator and whole fraction. So it's equivalent. Let's look at the next one. They have x minus 12 up here. They have x minus 12 here. Are those the same?
Yeah.
Yes, so they haven't changed that. This is minus, oh, there's no sign anymore, so they must have changed the sign in front. This is x plus 1. They have negative in front of x plus 1. So they changed the sign in front and they changed the sign of the bottom. Is that 2 sign changes? Yes, so that's equivalent. The last one, because this choice B is looking pretty good. The numerator, same. Sign in front of the fraction got changed. Denominator, it was x plus 1. Now it is negative x minus 1. Did they change everything about the denominator? Yes. Then they changed the sign in front and all of the denominator, so it is equivalent. So it is choice B. What we would find is that in C, one of them, at least one of them, is not equivalent to this. Well, this one, well, I really don't even want to go any further with this. I wanted to explore it just a little bit. The main thing I want you to get out of this question is a fraction has 3 sign positions: the numerator, the entire fraction sign, and the denominator. And if you change 2 signs, it's equivalent. If you change 2 signs, it's equivalent. That will be somewhat helpful. There's one and only one question like that in MathLab. Okay. Let's go on. So there are 3 questions that start out asking you about domain. How do you find the domain of a rational function? What do? Set the denominator equal to 0 and solve, and that's what you can't let x equal. X cannot equal the answers. All right, then there's that one question about signs. And now we're going to spend our time simplifying rational expressions. Now, simplify is probably the most overused word in algebra because it means different things depending on the setting. In this setting, simplify is going to mean reduce. You're going to reduce to lowest terms. Now, arithmetic fractions. Let's suppose we have 10 over 15. How do you reduce that fraction? You divide. What do you divide into the top and the bottom? 5. Because although you might not even want to say the words, you're looking for the greatest common factor. 5 goes into the top and 5 goes into the bottom. Now, what nobody ever writes down is the following: that 10 is 2 times 5 and 15 is 3 times 5. And because 5 is in common, you can divide it out, and you are left with 2/3. You probably would not write all of this out because it's numbers. With polynomial fractions, we're going to do factoring, which we spent all of Chapter 6 working on. How do you factor things? Then we're going to be looking for common factors, and we're going to divide them out. Okay? Now, let's start with problem number 5. I'm going to rewrite it so those of you in the class can see it. The instructions say simplify the expression. We know that means reduce. That is x plus 3 over 3 plus x. The first thing you're going to need to ask yourself about any rational expression is, can I factor the top? Can you factor x plus 3? Well, is there a common factor? No. It's a binomial. Is it squares? Is it cubes? No. Then the answer is no, I can't factor that. Okay? Since I can't factor it, I'm going to just write it as x plus 3. I'm going to go ahead and put it in parentheses, and I will explain shortly why it's important to put it in parentheses. If you can't factor something, then just put it in parentheses. It is a prime factor all on its own. All right. Now, the denominator. Can you factor 3 plus x? No. That is not an essential step that I've just written down, putting those in parentheses, but I think it's probably a good idea. Now, do you have a common factor in the top and in the bottom? The thing about the parentheses, it is all or nothing. Never, ever reach inside of a polynomial that you've put in parentheses and mark through one term. You can't do it. X is not a factor of the top. It's all x plus 3 or nothing. Okay, so if you start to reach into parentheses, you pretend that I have gotten out a ruler and slapped your hand. Okay, that is figurative. I don't want any lawsuits about me hitting you with rulers. I want you to visualize it, though. I will come after your mind with a ruler. Okay, so I can't reach in here. Well, is x plus 3 the same as 3 plus x? Okay, those of you who had 307 recently, do you remember what property says x plus 3 is the same as 3 plus x? Which one? The commutative property. Yay. Okay, somebody remembered. All right, so x plus 3 is the same. This 3 plus x could be written as x plus 3. They are the same. That was commutative property. So, can I reduce this fraction? I've done a whole lot of stuff and I might not have needed to. Do you see the same factor on top as you do on bottom? What's the same factor? Not x, but x plus 3. This entire thing, x plus 3 over x plus 3. When you divide out the common factor, what are you really leaving behind? 1. The answer is 1. Anything over itself is equal to 1, with the exception of 0 over 0. All right, what you were actually supposed to notice from this entire problem was that x plus 3 and 3 plus x are the same factor, which takes us to number 2. All right, it's not number 2, I'm sorry, it's number 6. It says simplify the expression, and it starts out with x minus 9 over 9 minus x. Okay, can you factor x minus 9? No. So it is an entity as a group. You can never go in and do something to the x or something to the minus 9. It is an x minus 9 thing. All right, the denominator. Can you factor 9 minus x? No. Now, in problem number 5, 3 plus x and x plus 3 were the same value. Are these the same?
Yeah.
Okay, I'm getting one yes and I'm getting one no, and a lot of uncommitted. Okay. Did the commutative property hold true for subtraction? Well, think of one. Is 5 minus 2 the same as 2 minus 5? No. Yeah, if you think they are, don't get a checking account. Because if you subtract the wrong way, oh, I've got $5 in the account. I'll write a check for 20, no problem. Yeah, we'll have a little bit of a problem. So, these are not the same. Well, do they have any kind of relationship? But what is their relationship? Opposites. These are opposites. If I used a little example, so I've written that those are opposites. What if I had, and I'm just going to go down here, what if I had 4 over negative 4? What is a number divided by its opposite? It is negative 1. It's not 1, it's negative 1. So if I have these two that are opposites, if I think I can divide those out, I can, but what am I left with? Negative 1. You are left with a negative 1. When you divide out opposites, you are left with negative 1. No, they were not, but good question. They were in different positions, but take a look at them. The numerator had an x, it was positive, so did the denominator. The numerator had a positive 3, so did the denominator. They were the same. But if I look at this one, the numerator had an x that was positive, but what about the denominator? It had an x that was negative. The numerator had a 9 that was negative, the denominator had a 9 that was positive. They were opposites. All right? So, You're hoping to see either identical factors or opposite factors so that you can divide them out. Now let's go on to other problems. Let's look at number 7. I have 5 over 40a minus 35. I'm supposed to simplify this, so I would wonder if I can maybe factor some things. Now 5 is just the number 5. I'll just keep it. Can you factor the denominator, 40a minus 35? What's the first thing you look for in factoring? Greatest common factor. Is there a common factor between 40 and 35? And it is 5. And if I divide 5 into 40a, it goes 8a times. And if I divide 5 into 35, it goes 7 times. The numerator could not be factored any further. The denominator could. Now looking at it, now that the factoring is done, do you see any common factors? 5. It's not in parentheses or anything. This 5 divides out with this 5. Now sometimes I get a little lazy and I don't write down the little ones that are actually being left behind when you divide out. What am I left with ultimately here? 1 over 8a minus 7. It is very important that that 1 be written as the numerator. You don't have to have parentheses. Now, on a paper pencil test, I would be fine if you left parentheses. I honestly don't know what Math Lab's reaction to it would be. I'm afraid it might not like it. But then again, you know, I'm not sure.
Is it the same saying 5 goes into 5 one time?
Yes, it is. 5 goes into 5 once, 5 goes into 5 once. But I still have this factor down in the bottom, so I have to have my 1 left over up there, and 1 times that is that.
I'm saying like dividing 5 into 5. And
Yes, yes.
Instead of bringing it over.
You mean divide?
Yeah.
Well, you could, but that's kind of particular for this problem. I suggest that you do your factoring. I'm going to encourage you, when the instructions say simplify, that the first thing you do is factor the top and factor the bottom if you can. Okay, let's go on. What number are we? We are on number 8. I have 5x minus 15 over x squared minus 3x. If someone asks me to simplify, do not touch the problem till you factored. Don't touch it till you factored. So if you're sitting there and you're going, oh, I think 3 will go into 15, I am coming after you, okay? Ruler in hand. You haven't factored yet. You can only divide out factors. And by the way, I have got a big one. All right. Can you factor the numerator? Yes. What do I do? Common factor of 5. So the numerator will be 5 parentheses x minus 3. The denominator. Do you see something you can factor down here?
Yeah.
Common factor of x. So it's x times x minus 3. Do you observe a common factor?
Yeah.
The common binomial, x minus 3, x minus 3. I got to mark it off because it was repeated in its entirety. Never reach in there and just take the x. Coming after you. Whole thing. So what's my final answer when I reduce this? It is 5 over x. When you simplify a rational expression, you must factor the numerator, factor the denominator, and divide out common factors. Okay, let's look at problem number 9. And I hope that I can write so that y'all can read this okay. All right, I have x plus 5 over x squared minus 4x minus 45. Can you factor the numerator? No. So just put it in parentheses. That will remind you that it is a binomial and must either be left as a group or divided out as a group. Now this denominator, this is a trinomial. There's no common factor. So here I go with trial and error. The last sign is negative. So what does that tell you about the two signs? One of each, one plus, one minus, x and x. I need two numbers that multiply together to give me 45. They will have a difference of 4. 9 and 5. And because this is negative 4, I want the big number, the 9, to go with the negative. Now, you just can't help but notice that you're practicing reducing or simplifying. Most problems are rigged, so they can be reduced. So it's no big surprise when you get an x plus 5 on top and bottom. As a matter of fact, you feel like, oh yeah, I must be doing this right. Most of these problems, perhaps all of these problems, can be reduced. They always give you the option, though. Type in if the expression cannot be simplified. All right, but in this one, the x plus 5's divide out, and what will I write as my answer? Okay, 1 over x minus 9. If you leave out the 1, is that a problem?
Yeah.
Yes. A numerator of 1 must be written. A denominator of 1 can be implied. All right. Let's look at 10. Number 10, I have 3x squared minus 2x minus 5 over x plus 1. Well, right away I noticed that I'm not going to be able to do anything with my denominator. Do y'all agree? Okay, so x plus 1 is going to stay there. The numerator has no common factor. It's a trinomial, so I'm going to go with trial and error. But let me show you something that's going to be helpful. I look at that and I start out and say, well, I can do the signs. The last sign is negative, which means one of each. Now, I'm going to show you something sneaky. In a real-life problem, this probably wouldn't help you much. But in an academic classroom problem, it will. What do you think one of these factors just might end up being? X plus 1? You know, because you're hoping you get to reduce this thing. So, to get a 3x squared, I need a 1x times a 3x. So I'm going to put the 1x here and the 3x here. Why did I put the 1x there? Because I think I'd like it to be with the plus sign. To get a 5, I've only got 1 times 5. I'm going to put the 1 there and the 5 there. I haven't checked it yet, but I bet that's right. The outer product is negative 5x. The inner product is 3x, which gives me negative 2x, which is right. Was the problem rigged? Yes, and I don't see any reason to keep that a big secret. The x plus 1's divide out. Lots of times you can anticipate a particular factor to show up. So what am I left with? I'm left with 3x minus 5. Do I write a denominator of 1? No. It is over 1, and you never see that written. Because when something's over 1, it's being divided by 1, you don't need to show it. So all you will find is that. You don't write denominators of 1, but you do write numerators of 1. So, do you think, so far, do you think you could do section 7.1 if you didn't know anything about factoring? No. You couldn't do anything in this lesson if you don't know about factoring. So, it's a good thing we know everything about factoring. All right, number 11. I have x to the third plus 11x squared over x squared plus 9x minus 22. I am supposed to simplify this. And what do I have to do in order to simplify? Factor. Okay, the numerator. Is there a common factor? Yes. X, and what power of x can I take out?
Second.
Yes. So x squared, that will go into x to the third x times, and it will go into the last one 11 times. Over this trinomial. No common factor. Let's see. Can we use our little sneaky thing? What do you think one of the factors will end up being? X plus 11. I hope so. We'll see. I need one plus and one minus. I need an x and an x. Factors of 22 that have a difference of 9. 11 and 2. And sure enough, there's my 11 and there's my 2. What do you see as common factors? X plus 11, x plus 11. What does that leave me with as an answer? X squared over x minus 2. Now, I can go get my red color again, and should I mark these out? This x minus 2, was it in parentheses? Do not touch a term of a binomial that has been in parentheses. Now, I don't know whether MathLab would let you put that in or not. It would be a good thing if you could, because it says this is an entity all on its own. You can't mark out part of it. X is not a factor of the denominator. A factor means it's times something. X isn't times something, it's added or subtracted. So don't touch it. I don't know whether you get to use those parentheses in your final answer or not. Is that okay? Number 12. I have two.
So like
Yes.
on number 9, I'm sorry, Ms. Nutter.
Uh-huh.
So like on number 9,
Yes.
it was 1 over x minus 9, so that didn't have to be in parentheses?
Right. It didn't. It had been in parentheses over here. It was in parentheses. But usually, when you finish the problem, if, say, you have a binomial and it's not times anything, you just wouldn't write the parentheses down. I personally don't mind them. I can't tell you off the top of my head whether MathLab would mind them or not. Okay. Yeah. Sure. There it is. Oh, okay. Oh, okay. That would not be factorable. You're right. All right. So 212. It is 2x squared minus 32 over 8x minus 32. Well, how about I go ahead and mark out those 32s right now? No. I'm getting some head nods. I can't mark anything out because I haven't factored. Okay, factor first. Factor first. All right, that numerator. What can we do with that? 2. 2 is a common factor. Always look for the common factors. If I factor out the 2, that will leave me with an x squared minus 16. Now, we factored it out, but I'm looking at this binomial, x squared minus 16, and I'm thinking maybe we can factor further. Do you recognize it? Yes, isn't it the difference of squares? So I will take one more step and say that's 2 times what? How do you factor the difference of squares? X plus 4 and x minus 4, a sum and difference of their square roots. So to factor the entire numerator took me 2 steps. The denominator, common factor of 8. Factor out the 8, and that will leave me with an x minus 4. So I can't do anything more to that, so I'll just copy it down as 8 times x minus 4. Do you see any common factors?
Yeah.
What do you see? Okay, x minus 4 is a common binomial factor. Okay, what about with the 2 and the 8? Those are monomial factors. They are common factors out in front. You can reduce those. 2 goes into itself once, and 2 goes into 8 4 times. So let's see what I have left over. The numerator, I have 1 times x plus 4, which is x plus 4. The denominator, I have 4. Oh, well, go ahead and mark out the 4s. No, because the x plus 4 came from those parentheses, and it's all or nothing. So, personally, I wish it was left like that, but I don't know that MathLab would like that. Because that would make you realize, or maybe visually clue you, don't touch it unless you see another one exactly like it. Is that okay? All right, let's look at 13. There are quite a few of these, but we need to practice a lot. Okay, 13. The numerator is 36 minus x squared over x minus 6. I don't believe there's anything I can do with that denominator, so I'll just go ahead and put it in parentheses. The numerator, what can I do with that? Right, it's the difference of squares, which means it factors into a sum and difference product. It will be 6 plus x times 6 minus x. If a particular kind of factoring is giving you trouble, say the binomials, you would want to go back and review section 6.5. If trinomials are giving you trouble, maybe go back to 6.2 and 6.3. If greatest common factor is giving you trouble, go back to 6.1. All righty, I have everything factored. Do you see any identical factors?
Yeah. X minus 6. Oh, no.
Okay, not quite identical, but you did see a relationship. That's good. But you need to make sure you see what the relationship is. You have 6 minus x and x minus 6, and those are not the same. What are they? Opposites. Okay, so I can get rid of those, but what do I have to leave behind? A -1. So just put it somewhere. -1 times whatever's left over. When you mark out things that are identical, you don't even worry about the ones that you leave behind. But when you mark out things that are opposites, you have to make sure that you leave a -1 behind as a factor. All right, my answer now is, I could write it as -1 times 6 plus x, but most probably they would go ahead and multiply that to be -6 minus x. You could try leaving it like that in factored form, but it probably wouldn't like it. So when you divide out opposites, you leave a -1 behind. Yes, ma'am?
The negative sign, does that have to be on top of it, or?
It doesn't matter. Since there wasn't anything left on the bottom, personally, I tend to leave it on the top. Okay? So watch out for those opposites. Let's look at 14. All right, I'm going to need a little room for some factoring here, because look at my numerator. I have x squared plus xw plus 3x plus 3w, and it's all over x plus 3. X plus 3 is a denominator. There's nothing I can do. But what do you notice about the numerator? What technique do you think we ought to try? 4 terms. Grouping. I am going to go off to the side, and I'm sorry about this. It's not the most efficient way to do this. I'm going to just look at that numerator. I have x squared plus xw plus 3x plus 3w. And I'm going to do my grouping. I have the first group and the second group. What's the common factor in the first group? X. So that's x times x plus w. What's the common factor in the second group? 3 plus 3 times, divide it, x plus w. Is this working out okay? Do you see an x plus w and an x plus w? Okay, so I will write it down in front, x plus w, and what's the other factor? X plus 3. So I'm going to take this and put it as my numerator. The numerator is x plus w times x plus 3 over x plus 3. Do you see a common factor? Yep. The x plus 3's divide out, and what are you left with? X plus w. Probably would not see parentheses, definitely would not see the denominator of an implied 1. There is a 1 on the bottom. You don't write denominators of 1. Okay, we've done difference of squares, we've done greatest common factor, we've done trinomials, we've done grouping. What have we not done? Cubes. Okay, well now we're on number 15. We're going to have some cubes. So somebody needs to make sure they've got the calculator ready to take a cube root for me, please. I have x cubed plus 216 over x plus 6. Do you recognize the numerator as a binomial, no common factor, but it does have a cube in it? Okay. Cubes, the sum of cubes factors into a binomial times a trinomial. So we're going to try to remember that pattern. What's the cube root of x cubed? X. Keep the sign. What's the cube root of 216? 6. The trinomial is formed by square the first, x squared, change the sign, product, which is 6x, and square of the last, 36. That kind of trinomial, which is square, change the sign, product, square, can't ever be factored any further. You'll always just leave it. And it's over an x plus 6. Do you see a common factor? Yes. X plus 6, x plus 6. What is your answer? X squared minus 6x plus 36. No, it can't be. That can't be factored any further, because the trinomial you get is always a prime when you're doing sum or difference of cubes. And it's over 1, so I don't put the over 1. All right. This is our last one, number 16. I said it's our last one. There really is something else I need to discuss that's in a couple of problems that I think I left off. Okay. This one could be tricky, but I'm going to show you something about it because there's no reason for you to be tortured with this problem. All right, the numerator looks like a pretty ugly, y'all probably can't even see that in the back of the room. I'm sorry. Let me rewrite it. I have 49x squared minus 56x plus 64 all over 343x cubed plus 512. Okay, I'm going to work down this time. This numerator, I just kind of want to ignore it for just a minute and I'll show you why. Okay, so I'm just going to put my fraction line. Because my first reaction is, oh my goodness, that's a trinomial and those are big numbers. That might take me a long time. So I'm just going to put it on hold for a minute. And let's look at the denominator. Yeah, the numbers are big, but would somebody test them for me and tell me whether they are perfect cubes? Is 343 a perfect cube? And its cube root is? 7. Okay. Is 512 a perfect cube? Yes, and its cube root is? 8. Okay. This is the sum of two cubes. So I'm just going to go ahead and do something that is easy, something with a pattern. The cube root of 343x cubed was 7x. Plus sign. The cube root of 512 is 8. Now I can build my trinomial, square the first one, 49x squared, change the sign, minus the product. 7x times 8 is 56x. Whoops. Hang on, it's cranky. Okay, sorry about that. And square the last one, 64. I did a square, change the sign, product, square. Look at the numerator. Isn't that what the numerator is? Okay. This pattern where you have a square, and it doesn't matter whether that's plus or minus, the product and the square, when you have that, it's always prime. Now, I know that because I've done so many problems, but you would probably spend a lot of time working on that. I'm not going to give you a test question like that. But do you remember that the trinomial is always prime, which means this numerator can't be factored either. Just copy it down. It can't be factored. But do you see a common factor? Yes, this big old trinomial is the common factor. When you get to number 16, you can sort of anticipate that happening. So what are you left with? 1 over 7x plus 8. Well, when I got 49x squared minus 56x plus 64, when I got it as the trinomial here, we have already kind of a rule that says that trinomial can never be factored. Since that's what the numerator was, that told me the numerator couldn't be factored. It's the exact same thing. And I had the advantage of already knowing that because I'd already done the problem. Okay. I neglected to include in here, excuse me, number 17, so I'm just going to write it in. And it says, it says find f parentheses 2, comma, f parentheses 0, comma, and f parentheses negative 1 if f parentheses x is x plus 15 over 9x minus 3. Now let me put this up. Those of you who were with me recently in Math 307, you might recognize this as a function notation problem. This is function notation. We spend more time on this when we finish chapter 7, but it does peek into this lesson. All right, function notation. It says, first of all, find f of 2 is how that should be read. Find f of 2. Well, look at your formula. Here's your formula. Do you notice that the 2 has been put in the place of x? So you put 2 in the place of x in its definition. That is 2 plus 15 over 9 times 2 minus 3. Does everybody see what I did? The instruction said to find f with a 2 there. So put the 2 where the x is. Evaluate that. 2 plus 15 is 17. 9 times 2 is 18. Subtract 3 from it, 15. Can you reduce that fraction? No. It's improper, but I don't care. The answer, 17 over 15, is a completely acceptable answer. That's your first answer. Next, it says, find f of 0. So what is it asking you to do? Put the 0 in the place of x. So it's 0 plus 15 is over 9 times 0 minus 3. Well, the numerator, 0 plus 15 is 15. 9 times 0 is 0. Subtract 3 is negative 3. Because 9 times 0 is 0, so that's gone. And then 0 minus 3 is negative 3. Can you simplify that? Yes, that's negative 5. So sometimes you'll get an integer value. The last part of the question says to find f of negative 1. So f of negative 1 will be negative 1 plus 15 over 9 times negative 1 minus 3. Negative 1 plus 15 is 14. The denominator, what's 9 times negative 1? Negative 9. Negative 9 minus 3 is negative 12. Can you simplify that answer? Yes. What's the common factor? 2. Because those are numbers, we'll just divide them out. We'll get 7 over negative 6. Now, question. That's certainly an okay answer. What's a different way it could be written? Not as a mixed number. Don't give me that. Just deal with signs.
Negative sign would be out.
Yes. The negative sign, this could be or, it could be negative 7 over 6. I changed 2 signs. I changed the negative of the denominator and I changed the sign out in front. There's one more. It could be negative 7 over positive 6. Any of those would be fine. Remember the 3 positions. Is that okay? I would just leave the one I got. But certainly any of them would be fine. And there is one more question, but it's another one of these. It's another one of these function notation. Okay, then we're going to call it quits on this unit, on 7.1, and we're going to take a look in just a second at 7.2.